Hey everyone, welcome back to another iBuddy video, and in today's video I think it's going to be our last trigonometry lesson. But this lesson is also extremely important, so pay close attention and do the examples as I go through them. So today we're going to be talking a really important topic that's extremely useful in real life. But before we begin, please ensure that your calculator is in degree mode and not radians, because we're going to for the topic that we're going to be doing, we're going to be utilizing cosine law, sine law. So that requires your calculator to be in degree mode, and you also should know how to use tan inverses, sine inverses, cos inverses. Cool? So today we're going to be talking about bearings. So what are bearings? So we don't know that yet, so I'll explain them to you. So bearings are really important to describe directions accurately. So before we start, think about this. If I tell you that a location is northeast of me, that's helpful, but it's not extremely precise. What if I wanted to tell someone the exact direction they need to travel? That's where bearings come in. By the end of this lesson, you should be able to read, calculate, and use bearings, as well as understand how the quadrant affects the angle we calculate. So what is a bearing? A bearing is an angle used to describe a direction. There are different ways we can describe directions, but with true bearings, which are the ones that are being mentioned here, we begin and measure the angle from north and go clockwise. So we start from north, we measure clockwise, we write the bearing using 3 digits. So always remember that you write the units, the bearings as 045, 090. Cool? So north is going to be 000, east is going to be 090, south is going to be 180, and west is going to be 270. Cool? So for 2-digit angles, make sure that you put a 0 in front of them. So now, let's imagine we're standing at the center of a compass. North is at the top, east is to the right, south is at the bottom, and west is on the left. So if I turn clockwise from north to east, from here to here, I have turned 90 degrees, so the bearing is 090. If I continue clockwise to south, I've turned 180. So if I go from north all the way to south, I have turned 180 degrees. Then if I go from north to west, that's 270 degrees, right? And if I go back a full circle, that's 360 degrees, which is also equivalent to 000. So the entire bearing system for true bearings goes 000, 090, 180, 270, and 360. Sorry, this is the entire bearing system, not only true bearing. This is also applicable for quadrant bearing. But quadrant bearings are a bit different. Cool? So in this, we get a reference angle. And they tell us that north 45 east. Cool? North 45 west. So you start at north, and let's say they tell us north 45 east. So you go 45 degrees to the east, right? And now let's say we're at south, right? And they're like south 45 east. So you go south, this is your south, and you go 45 towards the east. Cool? So let's say they say north 45 west. So you're at your north, and then you go 45 to the west. So in this, you're not only going clockwise, but you're going based off of the reference angle. So if they say, let's something like north 45 west, you're going looking at your north or south, depending on what they say, because they can also say south 45 west, right? And then you look at that angle. So for this case, it's north. So north, and then you go 45 degrees. How much is a 45? So if this is your west, half of that. Because one quadrant or one-fourth of a circle is 90 degrees. Because a circle is 360. So one-fourth divided by 2. I'm being a bit complicated here, but 45 degrees is half, so this much basically to the west. Cool? And then you make a line there, and that's your north 45 west. Cool? We get it? Good. If you need to understand it more, you can go back, or you can ask questions. You can email iBuddy, you can text, because asking for help is the best thing that we can do. Also, the quadrants. So north to east is 0, 0, 0 to 0, 9, 0. South to east is 0, 9, 0 to 180. Like, it's like northeast is 0, 0, 0, 0, 9, 0. Southeast is 0, 9, 0, 180. Southwest is 180 to 270. And northwest is 270 to 360. So this is your northeast. This is your southeast. This is your southwest. This is your northwest. Cool? Now, let's try a word problem using everything that we have learned about bearings. So for this, we're going to be using a whiteboard, which I think I prepared. Where did the image go? Why? Oh, no. The image left us, so I'll get it again real quick. Sorry about this, downloads. Where'd it go? Home. Right here. Cool? So this is the question. An airplane flies 400 kilometers on a bearing of 55 degrees. So we're going to assume, or we know, that it's true bearings. So let's draw this out. Let's turn on the line thingy. So they're saying that an airplane flies 400 kilometers on a bearing of 55. So when we look at the question, before even reading the question, make yourself a north or like a south straight line. Cool? And that's where we're going to be getting our like directions and stuff from. Cool? Let me like make this straight if I can. So we know that it's the north. Cool? This is our north line. Let's put like an arrow on top because it's going to keep going. Cool? So now they're saying that an airplane flies 400 kilometers on a bearing of 55. So we know that this is like 90, right? Like, oh my God, another straight line, sorry. Right? So we know that this is 90. We know that this is 90, cool? So they're saying 55. So 55, like, you can like rough hand it. You don't have to use what's it called? Like the thing that helps you measure angles. So you can just like use your eyes and like hands and just assume that this is 55 degrees. You don't have to be like really precise. Let's say that was 55. So I draw a straight line. Use a ruler. Rulers are really important. Cool? I'm going to erase this line because we don't need this and that's just going to get me confused. And I put 55 degrees here. 55. And I put 400 kilometers here. 400 kilometers. Cool? Now they're saying it then flies on a bearing of 300 degrees. Oh my God, I might have to like zoom out a little bit and go. And this is good. Cool. So now they're saying that it then flies on a bearing of 300. So again, we draw another north line from the end, from where we ended after the 400 kilometers. We draw another north line. Cool. We make the arrow on top because the north line keeps going. And then we find our 300 degrees. So what was 300 degrees? It lies between northwest, right? So we take the pen. This is 90. This is 180. This is 270. And somewhere here is 300. So we draw that line. Where's my line tool? So we take this, right? We draw this line, and they're saying that it ends to the north. So it says until it's due north of its starting position. So somewhere around like in front of the arrow, so somewhere like here. Cool? And now we can join these because they said due north. So like this is a straight line. Cool? So we have a triangle, right? So first let's label 300 degrees. Cool. And we don't know anything else, right? We don't know anything else. So how far is the airplane from its starting position? So where did the airplane start? It started right here, right? Because it went 55. So this is our starting point. So let's label it S. Right? and this is our ending point. So let's label it E. So we got to find this line. Cool? So now let's use our angle knowledge. So we know that this is 300, right? If this is 300, how much is this angle going to be? It's going to be 60. Yes, why? Because you remember a circle is 360 degrees. And this area is part of that circle. It's like we have 8 pies and 1 pie is taken from that circle. So that pie, let's assume in this case, was 60 degrees. But if it was 280, then it would have been 80 degrees. So you got to look at what you have. So in this case, this is 60 degrees. Cool? This is 300 degrees and this is 055 or whatever. Cool? 060. And then let's use our angle knowledge, like the alternating angles. Because look, this, I'll highlight it. This forms a Z. Oh my God, why is it so not? This forms a Z pattern, right? Right? We see it, we see it, we see it. Yes, cool. So that means that this angle on top is the same size or the same like angle as this angle at the bottom. So this is going to be, oh my God, I hate this pen. It's going to be 60 degrees as well. Cool? So we know this angle, we know this angle. So what do the angles in a triangle add up to? Yes, 180. Oh my God, I can't type. Sorry guys, sorry. I apologize for my mouse skills. I can't utilize a mouse. So 180, right? Let's say this is 180. So now we know that 180 minus 60 plus 55 is what the top angle is, right? And that is 65 degrees. Cool? So we know that the angle, this part, is 65 degrees. Cool? And now, what can we use to solve this? We have one side and 3 angles. And we're trying to find another side. Yes, we can use the sine law to solve this. So we can do, let me see if I can actually type. That would be easier for you guys to understand. Let's zoom in a little bit. Cool. Let's make the size bigger. Oh my God. Let's do it here. 72. Let's say, my God. Why isn't it letting me type? Let me type. I don't know how that works. Oh, it works. Perfect. But I want to like increase the size. So like this. Alright, you guys can see it. I'll zoom in like now. Perhaps. Because we remember the question, right? Not that much. So, okay. We know that it's 65 degrees, right? So the angle on top. And we remember that the top is 60. So the angle that's opposite to 400 kilometers is 60, right? So we can do what? We can do 400 divided by sine of 60 because this is sine law, right? Why did I put 100? No, 400 divided by sine of 60 is equal to what? Is equal to x, or whatever you want to label and call, or we can call it the line of ES, right? With the line on top. Oh my days. Okay, I'll just do it with the pen. Guys, bear with me. Sorry. So 400. Oh my days. Sorry. Technical difficulties. This has never been a problem before. A bit bigger actually. Like this big. Cool. So 400 divided by sine of 60 is equal to x, or like line of ES over sine of 65. because that's the opposite. If you remember, like if I like zoom out a little bit and zoom in like a bit on top of the triangle, why is it not like letting me? Let's zoom in a little here. So this is the opposite. We're trying to find this line, right? This I'll highlight it with like I don't know, highlight. Let's do orange. So this is the line that we're trying to find, right? And let's say line ES. Cool. So now we're going to solve this. If it's being divided on this side, when it goes there, it's going to get multiplied. So 400 times sine of 65 divided by sine of 60. Cool. And what does that give us? You can do it other ways too. You can do 400 divided by sine of 60 times sine of 65. And that gives us our answer to, let's say, the nearest tenth is going to be 418.6 kilometers. Always ensure that you put the unit. Cool. And now let's go back to our presentation and see if we did it right. Cool. Present. So yes, we did it right. It's 419 kilometers. So I rounded it to the nearest tenth. This one was 419 kilometers. It's the same thing, depending on what the question asks you to round to. So now these are some practice questions for you for bearings. I'll just read them out to you and give you a little hint if I believe that it's hard. A private plane flies for 1.3 hours at 110 miles per hour on a bearing of 40. Then it turns and continues another 1.5 hours at the same speed, but on a bearing of 130. At the end of this time, how far has the plane traveled from its starting position? Okay, this is like the exact same question. The only thing that it might differ in is like you don't end due north, but it's gonna end up either using sine law, cosine law, like whatever. But it's the same concept that we just did. So make your diagram and follow your diagram and follow your gut and feelings. Next question. Two ships leave a harbor at the same time. One ship travels on a bearing of south 12 degrees west. So this is our quadrant bearings. Cool. South 12 west at 14 miles per hour. The other ship travels on a bearing of north 75 east at 10 miles per hour. How far apart will the ships be after 3 hours? Round to the nearest tenth of a mile. So this is challenging, and I believe that I've taught you enough in this lesson that you should be able to do this. If you can't, don't worry. We're all learning as we get older. Like me too, I keep learning every day. So it's not hard to ask AIs for help. Like, ask it for help. Don't ask it to do for you. And even if you ask it to do the question for you, ensure that you're asking it to give you another question like that so you can like check up on your learning. Cool. And that brings us to the booklet. This is like a booklet I made based on trigonometry. I can't give you the link because I'm not gonna be able to send it in on the app. So you can like type it in if you need it, or you can just search up trigonometry booklet grade 10 or trigonometry booklet, bearing booklets, or like whatever concept that you need help with, and find a booklet or like find questions on Google to practice. And that brings us to the did I not have a thank you slide? And that brings us to the end of our lesson. And thank you for listening to me, and I hope that you understood bearings and now can actually solve the questions with bearings. I'll see you in the next video.